today we're gonna be doing the term 1 week 2 AMS quiz for chem. Now before I start solving this quiz, there is two disclaimers I have to make. One of the teachers in my school did say that a lot of the material in this quiz is material that is not required of us. When I see a question that I'm assuming isn't part of the material that's required, I will be telling you, but the teacher did say that check from CQD 1 to 15 and that's all the information required from us. Anything that's outside that information is not required. Now, I will be explaining every single question, but some isn't required, and there is one question along the way that is wrong, which I will be telling you about when we reach. And let's start. And based on the first question, I think it's one of the questions that's not required of us, but we're gonna read it anyway. Which of the following are the factors that affect the magnitude? So we need the magnitude of the lattice energy released when a pair of ions attract each other. Now, when you have a pair of ions, each one has a charge. So what do you think affects the amount of the charge? It's proportional to the distance between the nuclei of the two ions. So this means if the distance increases, the amount of energy released increases. If you think about it logically, it doesn't make sense. So if you have two ions that are this far away from each other, do they release more energy than if you had these two ions? Though the closer they are, it's obvious that the stronger they are. So this one is definitely wrong. It is directly proportional to the charges of the two ions. So let's say this one had a strong charge and this one had a weak charge. If the charge or the strength of the charges increases, does the magnitude of the energy released increase? Obviously. If this one has a weak charge and that one has a weak charge, the amount of energy released is not going to be that much. So it's directly proportional to the charges of the two ions. It is inversely proportional to the electron affinity of the ion. It has nothing to do with the lattice energy of ions. It is inversely proportional to the radius of two ions, which is basically saying the opposite of this. So it's telling you that it is inversely proportional, so that the more the ions are farther away from each other, the less energy released. Or in other words, the closer they are to each other, the more energy released, which is definitely correct. Let's move on to the next question. Now, thorium has 7 naturally occurring isotopes. Isotopes is a word we saw last year. Isotopes is basically when we have same protons and electronic configuration, but different neutron number, or in other words, different atomic mass. So that's the definition of an isotope. So what's the following is true of the isotopes? They have the same number of protons. We said yes. They have the same physical properties. No, they don't have the same physical properties because they have different number of neutrons. So naturally they can't have the same physical properties. They have the same number of neutrons. They do not. Oh, they have different number of neutrons. Yeah, my bad. Yes, they do have different number of neutrons. I read it wrong. They have the same chemical properties. Yes, you're gonna ask, why do they have the same chemical properties? If they have the same electronic configuration, they're gonna have the same chemical properties. It's only reasonable for them to. So the only wrong one is they have the same physical properties. They do not. Moving on. Thorium is a naturally occurring radioactive metal found at a trace level in soil, rock, water, plants, and animals. Its atomic number is 90 and mass number is 232. Now we know that atomic number is the number that's always written on the bottom, or mass number is always written at the top. And they have names. A, and Z. Mass number is Z and atomic number is A. Wait, I think I switched them up. It's mass number A and atomic number Z. Yeah, that's right, my bad, guys. So we know that always mass number A is up, atomic number Z is down. So the mass number, which is 232, is up, and the atomic number Z is down, 90. And then you just write thorium, TH. So this is the correct option. Moving on. Which of the following has different number of all three subatomic particles? So they're asking which of the following has different number of protons, electrons, and neutrons. Here you have 16 protons, so 16p. Then you have 16 plus 2 equals 18 electrons, and 32 minus 16 equals 16 neutrons. So we have 16 protons and 16 neutrons. So not all three of them are different numbers. So this is wrong. Now here you have 12 protons. 12 minus 2 gives you 10 electrons. But 24 minus 12 gives you 12 neutrons. Protons and neutrons equal, so this is not wrong. Now here you have 19 protons. And then you have 19 minus 1, so 18 electrons. And then you have 20, because 39 minus 19 is 20 neutrons. Protons is 19, electrons is 18, neutrons is 20. Are all three numbers different? Yes, they are. So this one is correct. Now we have this one. It's wrong, as you can tell, because 14 minus 7 equals 7. So then you'd have 7 neutrons and 7 protons. So this is automatically wrong. Now let's move on. Here you're gonna just do the exact same thing. Mass number is always the one on top. Atomic number is always the one on the bottom. So this question, I don't think you can really get it wrong for these two boxes here. These you should automatically get them correct because they're copy-paste numbers. 137, 137, 56, 56. I'm going to continue on to all of them. 27, 27, 13, 13, 80, 80, 35, 35, 56, 56, 26, 26. These numbers, you copy-paste them. Now, number of protons is always the same as the atomic number. It's always the bottom number. So just copy them the same. 56, 13, 35, 26. It's always a copy of the atomic number. So you copy the row behind it. Now, number of electrons is the same as the number of protons unless you have a minus or a plus sign after. If you have a minus 1, like here, you add 1 to the protons. If you have a 2 plus, you minus 2. If you have just a plus, you minus 1. It works opposite. Because when you have a minus, it gained 1 electron. But when you have a plus, it lost electrons. You get what I mean? So to get the electrons, this one is copy-paste protons. You copy it onto the next row. And this one too. For this one, it's minus. Br minus 1. So it's 35 plus 1. Because you gained an electron to make it minus. So it's 36. Here it's 26, 2 plus, so minus 2. 26 minus 2 is 24. Because you gave away 2 electrons. That's why you subtract. Now, to get neutrons, it's the most one that's different. To get neutrons, you minus mass number from atomic number equals number of neutrons. Mass number 137 minus 56, 81. 27 minus 13 is 14. 80 minus 35 is 45. 56 minus 26, 30. And that's how you get everything in this row or this table. Let us move on to the next question. So the atomic symbol of titanium is 48 over 22 titanium. What of the following about titanium is true? Is the number of protons 26? What did we say? Number of protons is always the same as atomic number. Here it is 22, so it is the 26. The number of electrons is 48. Here you do not have a charge, so what did we say? Number of electrons in this case is equal to number of protons. If number of protons is 22, then the number of electrons is not 48. Is the mass number 22? What did we say? Mass number is always the one on top. So the mass number is 48, not 22. Is the atomic number 48? No. The mass number is 48. The atomic number is 22. So this is wrong. The number of neutrons is 26. How did we find neutrons again? Neutrons equals to atomic number to mass number A minus Z, which is 48, minus 22, which is equal to 26. So this one is correct. Moving on. What's the symbol of copper? Now to write the symbol, we know that we write mass number up and atomic number down. Now here they didn't give us the mass number and the atomic number. We know copper is Cu. Now we know that atomic number is the same as number of protons. So you just write 29 down automatically. Now here they didn't give us a mass number, but we know mass number is equal to proton plus neutrons. It's equal to the number of nucleons. Nucleons are the things found in the nucleus. So it's 29 plus 35, which equals to 64. And that's how you write the atomic symbol of copper. Let us move on. Okay, so now we started with orbitals. What is the maximum number of orbitals that can be found on the third energy level? Now, I'm gonna make a quick explanation about the energy levels before I answer this question. Now, we have 4 energy levels. Energy level 1, 2, 3, and 4. Energy level 1 is called the S level. 2 is called the P, D, F. Now, for this, you need to memorize a few things. That S has 2 orbital, like it has 2 in it. P has, or like it has 2 sections, like it has 2 boxes, okay? P has 3 boxes, D has 5 boxes, F has 7 boxes. I think that you have to memorize these. There's no way to not. Now, when we want to find the number of orbitals, there's an equation. The equation is n squared. That's how you find the number of orbitals. To find the number of electrons though, the number of electrons in the energy level is equal to 2n squared. That's it. These are the 2 formulas you need to memorize for orbitals. So n squared, now we need to use n squared. That's how many number of orbitals are. Third energy level has 3 sections. What do I mean by 3 sections? And what do I mean by n squared or orbitals? So we need to take it as if it were a house. A house with 3 rooms. Each room has 2 beds. But we're not allowed to use the next room, or we're not allowed to use the next room until we're not allowed, to have 3 people in one room. We need at least 1 person per room before we can start filling the next room. So, and just know that each room can fit 2 people because it has 2 beds. This I'll explain in the next question or in a future question, because now I don't want to confuse you guys. Anyways, we just apply the formula. 3 to the power of 2 is 9. For the first energy level, it's 4. Second is 9. This is 25. And this has 49 orbitals. That's it, what you have to memorize for now. Now, let's move on. Okay, so this question has to do a bit with physics, but it's chem. The surface of a metal is struck by electromagnetic radiation of increasing energy. The electrons are observed to be emitted when the energy of the photons is this. So they gave us the energy of the photons. What is the wavelength, lambda, of the electromagnetic radiation that's caused by the emission of electrons? Now here we have a formula. I don't know if you remember, but we had the formula, what's it called? Energy equals we had 2 formulas that we've seen before. We had one that is new, or not really new. We've seen it in physics, but it wasn't really focused on. Energy equals Planck's constant h plus times frequency. Now in physics, we write frequency as F. In chem, we need to write it as a V with a squiggle at the end. That's how you write frequency in chem. So we have this equation, and we have another equation that we've taken in chem, which is velocity, or not velocity, my bad. Speed equals frequency times wavelength. So lambda times wavelength. Times lambda, which is wavelength times frequency. My bad. So we can combine these two equations into one equation, and this is the equation we're gonna use 90% of the time, which is energy equals to Planck's constant times velocity, aka not velocity, my bad. I call it velocity because it's a v, but it's actually speed of light specifically, which is 3 times 10 to the power of 8. So time hv over the wavelength. And this is the equation we're gonna use most times, but it's derived from these two equations. Because we have the frequency in common, you can rearrange one of the equations, or you can rearrange this equation. So frequency equals to speed of light over wavelength, and energy, or here velocity, or here frequency, equals to energy. No, it's equal to, my bad, it's equal to energy over Planck's constant, and then you could just energy over Planck's constant equals to velocity over wavelength, cross multiply. Long story short, you reach this equation. This is the one we need to use. So you always have Planck's constant and the speed of light. These are constants and they don't change. And in this question, we were given energy. We need to find wavelength. So energy, which is 4.19 times 10 to the power of negative 19, equals Planck's constant is given as 6.63 times 10 to the power of negative 34. I'm gonna delete this for now. Oh my gosh, I keep opening. Anyways, times speed of light, which is 3 times 10 to the power of 8, over wavelength. When you solve this on your calculator, you're gonna get a number like, wait, let me solve it on my calculator and tell you what number I get. You get an answer of about 4.75 times 10 power negative 7. Okay? Now here they want the answer in nanometers. Nanometers is negative 9. So to go from meters to nanometers, you have to multiply times 10 power 9. Okay? So the negative 7 is gonna cancel out, and this is gonna cancel out the 7, and you're gonna be left with 2. So 10 times 10 to the power of 2 becomes 475 nanometers. And that's how you get the answer for the first part. My bad, I cut off the mic by mistake. Now let me remove the solving and this. So it's 475 nanometers. Now 475, they also gave us a table of the color of the light and their wavelengths. You need to find what category does 475 fit into. By this, you just compare the number. Is 475 between these two numbers? Of course not. Is it between these two numbers? Of course not. These two numbers? No. These two numbers, it starts at 4091, so no. Is it between these two numbers? Yes. Is it between these two? No. So it is a blue color because it matches the wavelength of blue. Now let's move on to the next question. Okay, here we have the box, or the electron in the box configuration. Now here they're asking for the one that has the lowest energy. But usually when they give us this question, all of the options are wrong other than one. You're gonna ask me, how do you know if it's wrong or not? Look, whenever you're writing this, we need, later in a different question, I'm gonna teach you how to write electronic configuration in SPDF configuration. But now, before that, because I think SPDF isn't required in this week's AMS, but it's in the quiz, so I will teach you how to do it. But we need to know that S, it's always S1, S2. Or sorry, it's always S2, S2. But we have 1 S1, 1 S2, and 2 S2. Then we go to 2P6. So, what did I tell you about the houses? In one house, you can fit 2 beds. And you need to fit the room before going in. You need to fill all the rooms, at least with 1 person, before moving on to the next. And if you have 1 room or 1 box, you need to fill the box before moving on to the next box. Now, S is always represented by 1 box. That's what I told you. So, S is 1 box. P is 3 boxes. We need to keep this in mind. And I told you D is 5 boxes and F is 7 boxes. But I don't think they're gonna ask for this week's AMS. So when you have this S box and this S box, they're basically 1 room. To fill this room, you need 1 going up and 1 going down. And you are not allowed to move to the next box until you have the first box filled. So, and they both have to be in opposite directions. To fill up a box, that's 1 room, 1 up, 1 down. Now, how do you fill in a house with 3 rooms? You fill it in 1, then 1, then 1. Then you do the bottom, the bottom, the bottom. 2, 2, 2. That's how you fill up the other boxes. You cannot fill it in any other way. So let's look at our options and look which one is filled in the correct way. This box is filled because it's 1 house, it has 2 members, both going up and down. This one also. This one has 1 member, 1 member, 1 member. If you do not have enough electrons to fill the houses or the rooms, it is fine. You could stop at here because you only have 3 electrons to fill. But what we can't do is remove this and do that. No, you need to have at least minimum 1 person per box or 1 arrow per box before you can start putting the second arrow downwards. In B, what did I tell you? When you're writing electronic configuration, you have to start with S2, then you go to P. So here you only have 1 S, you're missing a box. So this one is immediately wrong. B cannot be the answer. Here, you have 2 boxes, then a 3 box, but if you look at this box, you have 2 arrows going up. You cannot have 2 arrows going up. You have to have 1 up, 1 down. So C is automatically wrong. Here, forget the fact they put a 4th box here. Now this one is right, but it's wrong because of another reason. Here in the question, they moved on to the P boxes or the P orbital without filling out the second S1. You're not allowed to move to the next one until you have 2 arrows in the S. Then you're allowed to move on. And here they moved on to the next S1 before finishing the P. So this is wrong. The only correct one now is A. That's the only correct form. The rest's form is wrong. Now, what's the classification of nitrogen? Nitrogen is a free radical. Why is it a free radical? It's because nitrogen exists with 3-. So it's ready to pair. If it's ready to pair and it's unstable, it's a free radical. If it's stable, it's not a free radical. Now nitrogen as itself is a free radical. But N3- is not a free radical, it's stable. Why? Because 3- means that it already took 3 electrons to become stable. But as long as it's not a noble gas, the element in itself cannot be stable. But N3- is stable. But as long as it can form or it can take in or give electrons, it is unstable until it does actually give or take the electrons. So as long as it didn't take or give electrons, it's classified as a free radical. Let's move on to the next question. Which of the following species is considered a free radical? Now, what did I tell you? as long as it can give or take, it is a free radical. Ne is a noble gas. Since it is a noble gas, it's already stable, so it is not a free radical. F9 can still be F minus, but it didn't take the minus, so it's still just F9. It still has 9 electrons and it's not stable. 9 electrons is not the number of electrons that a noble gas has. To know if it's stable, you need to compare the amount of electrons it has. If it has electrons like any of the electron numbers or any of the atomic numbers in the noble gases, then it's stable. I'm gonna explain what I mean. Cl isn't stable as chlorine, but Cl minus is stable. Why? Because the 17 electrons took an extra electron to become 18 electrons. 18 is the same number of electrons as argon, if I'm not wrong. Just let me check so I'm not giving wrong information. 18 is the same number, as argon. So argon is a noble gas that's stable, and this one has reached an electronic configuration that is stable. So this is wrong. Now K19 it gave away an electron. It was 19, it has now 18 electrons because it gave one away. So it reached noble gas configuration. It reached stableness. So it is now stable. So it cannot be considered a free radical. This is the only one so far that is a free radical. So basically, if it's a noble gas, or if it is a normal atom that has a charge, and that charge is the charge it's supposed to have, it cannot be a free radical. But if it's just an element that's not a noble gas, it is a free radical. Moving on. Which of the following has a half-filled subshell upon losing one electron? Cl, when it loses one electron, it becomes Cl18. Is the Cl18 stable? It is stable because it's now argon. So Cl minus, when it loses one electron, it's stable. N7, when it loses one electron, it has 8. Now, 8 is not the closest noble gas configuration to it. The closest noble gas configuration to it is 10. But you need still 2 more, because nitrogen is in group 5. So it's N3 minus. So you need 3 electrons. Is that half-filled subshell? It's not half-filled, because you only gave it 1 of the 3 it needs. Whereas Mg is 2 minus. Mg is 2 plus. So when Mg, it loses 1 electron, so it gives it away. It becomes Mg plus. Oh wait, it loses 1 electron. My bad, guys, I was explaining as if it were adding 1 electron for these two. These two, when they lose an electron, they become Cl plus. You can't have Cl plus, you can't have N1 plus. These are gases, they can't have a plus. But here, when you have Mg, it's Mg2 plus. If you give it, or if it loses 1 electron, it becomes Mg plus. Is that half of what it's supposed to have? Is 1 half of 2? Yes. So this one has a half-filled subshell. Whereas Na is already Na plus. So if it loses 1 electron, or if it gives away 1 electron, is Na plus what it's supposed to have? Yes. Whereas Mg plus is only half of what it's supposed to give. 1 is half of what Mg is supposed to give, so you can't consider it half-filled. So it is half-filled. Whereas Na cannot be considered half-filled because it only can give away 1. Moving on. Now, what's true about 2px and 2py? They are degenerate orbitals because they are orbitals on the same, they're on the same energy and sublevel. How do we know they're on the same sublevel? Because they're both p and they have the same number. Okay, so they have the same energy and same sublevel. They occupy the same subshell but different energy levels? No, because they're both on energy level 2. They are the same energy level but in different sublevels? No, they're not. They are hybridized orbitals? No, they're degenerate. When you have 2 and p, or 2 and p, or when you have the same number before and the same letter, then they are degenerate orbitals. The only thing is, in the houses, these are the names of the rooms. So this room in P is called X, Y, and I think it's Z. Yeah, PZ. So this one's called PZ, PY, PX. They all are the names of the rooms in P. And since they're both at the second energy level, it is fine. Now, moving on. Again, this question is the correct electron in a box representation. Now, listen, for this question, there's 2 ways of knowing the answer. First of all, we're gonna have most of the options are wrong except one, and we need to count for the total number of electrons in the end to be equal to 8. Now, what did I say? We need 1s2 and 2s2 before moving to 2p6. So we need 2 houses of 1 room before moving on to a house of 3 rooms. So first, I'm gonna cancel all the ones that start off with only 1 house of 1 room. So this one has 2. This one only has 1 house of 1, so it cannot be E. And I think that's the only one. Now, let's see what else is wrong. Is A wrong? Do we have 2 houses of 1 room before moving on to the house of 3? Yes. Is this one 2 arrows, 1 pointing up, 1 pointing down? Yes. Is this one 2 arrows, 1 pointing up, 1 pointing down? Yes. Do you have 3 pointing up arrows? Yes. Did you start filling out with the 1 pointed down? Yes. Can we count the arrows? We have 1, 2, 3, 4, 5, 6, 7, 8. That represents 8 electrons. So this one is correct. Now let's see what's the mistakes here. You have 2 arrows facing up, down, and 2 arrows facing up, down. And here you filled it up, 1, 1, 1. That's correct. But they moved on to a new sublevel, or to a new subshell, without finishing or filling up this one, which you are not allowed to do. So you're allowed to move. You need to put 1 person per room, then you add the second person to each room. After you fill up all the rooms, then you can move on to the next sublevel or subshell. This one, you have 1 room filled with 2 people, then you have 1 room filled with 2 people, but they did not follow how you're supposed to fill it up. I said you need to put 1 room per person. You need to go arrow up, arrow up, arrow up before you can start going arrows down. And they did not do that here because this box is empty, which you're not allowed to have unless you only have 2 arrows that are up without any more. So you can have, so let's say you saw this in the exam. Is this allowed? Yes. This is allowed as long as you do not have any more. But if you have any more and they put it in anywhere other than the 3rd box, like here or here, it's wrong. Unless they have like this, then you can start filling out the second person in each room. So this one is wrong. And this one's wrong. This one, you went up and down, you went up, but they moved on to the next energy level without filling up this one. They needed to put this, which is wrong. And even here, they moved on to the next sub-level without filling up this, which is a big, massive no. So this is the only correct electron in a box representation. Moving on. Now, I think this question is not required, but I'm still gonna explain. From what is the shape of the orbital from which an electron is lost? I think you need to memorize which one electron is lost, or an electron is lost is always the s orbital. Now, I'm gonna give you some notes. S orbital is spherical. It's a sphere. The p orbital is shaped like a dumbbell, like the thing they use to lift weights. The d orbital is shaped like a clover, like a 4-leafed clover. My bad. That's a very bad drawing. This is how the d orbital is shaped, and the f orbital is shaped like a 3D complex shape. So take these down as notes because you're gonna need them to know how each one is shaped. So whenever they say where an electron is lost, it's usually the s orbital. This is the 3D complex shape, by the way, option E. C and D are both the d orbital, and B is an example of the p orbital. Moving on. Now calculate the energy of a photon whose frequency is this. Now we know that here, what did they give us? They gave us frequency. They gave us Planck's constant, speed of light. Now, if they give us information, doesn't mean we need to use all of it. They said calculate the energy. So some people are gonna straight up go E equals h speed of light over this. Do you have the wavelength? We don't have the wavelength. So in this case, we go back to our original equation that states E equals to speed of light, or sorry, equals Planck's constant times frequency. So energy equals 6.626 times 10 power negative 34 times this number, which is the frequency. Multiply them together, you should get this answer on your calculator. Please, please, please do not forget your units. Now, in the quiz, they gave us all the units and you just had to put the answer. But in the exam, in case they do not and they wish to trick us, do not forget them, please. Moving on to the next question. Now, this question, I got a small mistake and I'll tell you where. But this question has showed up in many AMSs and periodics and finals before. Now, choose the number of isotopes. Isotopes, to see the number of isotopes, you need to see how many lines you have. 2 lines means 2 isotopes. To calculate the average atomic mass, we've been taking this for literally 3 years. You do the mass times the abundance plus mass times abundance over 100. So 35 times 75%, but you only do 75, plus 37 times 25 all over 100. Put that into your calculator, you should be getting an answer of 35.5, and that is your average atomic mass. Now here they said use the mass spectrum and the periodic table to give the chemical formula. They usually ask for the name. My mistake was I did not read the question and I just directly put chlorine. Here they asked for the chemical formula, so please read the question and be careful what they ask for, so you don't make mistakes like these in the exam. And by the way, they never brought this up in an exam, but I feel like they might. To calculate, when they give us the relative atomic mass or the percentage of how much it is, we all usually, there's a different formula that includes mass. They give us the mass of how much percentage by mass, but they don't give us an actual percent. When they give us a mass, it's mass times abundance. I don't know, abundance. Plus mass times abundance over mass 1 plus mass 2. Because sometimes they don't give us it as a percentage. Sometimes they give us just 2 masses. They don't give us the percentage of the mass. In that case, it's not over 100, it's over the sum of the masses. That's all I'm gonna say. They never brought it up, so I wouldn't really worry about it, but in case they do bring it up, I mentioned it. Moving on. Hopefully the questions moving forward go a bit faster because this video is taking long. Anyways, naturally occurring boron is composed of 2 isotopes, B10 and B11. The average atomic mass of boron is 10.81 AMU. Calculate the percentage abundance. Now we have the atomic mass of each. To find the abundance, it's 10 times, I'm gonna write times as a dot, x, plus 11 times 100 minus x, because it's whatever is left of the x, all over 100. equals 10.81. Now 10.81 times 100 gives you 1081 equals 10x plus 11, you distribute, so 1100 minus 11x, then you move this to the other side, so you get negative 81, I'm assuming. No, wait, let me just do it on my calculator really quick. So 1081 plus minus 1100, you get negative 19 equals negative x. So x equals 19, and then that means that 10x, or like that we gave x to be 10, right? And we gave the 100 minus x to be 11. By the way, you could switch them, but be careful what you give which to what. So the one we gave x to is 10, so this is 19%, and the second one would be 100 minus 19%, which is 81. Moving on. If you did the IG, there was a question like this in the IG. Thorium is a naturally occurring radioactive material. This, we read the question, its atomic mass is number, and the mass number is 232. The relative charge of the nucleus, and we know in the nucleus there's protons and neutrons. Neutrons are neutral, they have no charge. And we have protons now. The protons, each one has a charge of +1. How many protons do you have? The protons are like the atomic number. So if you have 90 protons and each one is +1, then you have a charge of +90. And here they said do not forget to include the sign, so you have to put the plus. Moving on. Here thorium is a naturally, we've solved this question before, but here they gave you, I think, no, they didn't give you isotope of it. So you just put mass number up, then you write atomic number down, and then you write this chemical symbol. Always, always, always the numbers are to the left of the chemical symbol. Moving on. Bromine radicals are produced by the homoelectric fission of bromine gas in the presence of light. They don't really care, they just want the number of protons, neutrons, and electrons. Now the number of protons is gonna be the number on the periodic table. So you need to go back to your periodic table and see the atomic number of bromine, which is 35. The electrons, since there's no charge here, is gonna be the same as the protons. And to find the neutrons, you do 80 minus 35 to get 45. Moving on. Here, we took it in physics before. The beam that deviates away from the positive plate. What do we know? Positive, repel. Negative, repel. Positive, negative, attract. And gamma rays, or neutrons, do not deflect. So the one that deviates, which means moves away from the positive plate, is going to be the positive ones, which are protons. The one that deviates or moves away from the negative plate is the one that's negative, electrons. And the one that does not deviate is the one without charge, the neutrons. Moving on. Here we have another question we've seen in physics before. Protons have a charge of +1 and they have a mass of 1. Neutrons don't have a charge and they have a mass of 1. Electrons have a charge of -1 and they have a mass of 1/1836. Sometimes they write it as 1/2000, but I'd prefer you memorize both, because both are things they usually write. Now, I told you, p orbital is shaped like a dumbbell, d orbital is shaped like a clover, s orbital is spherical, and the f orbital is a weird shape. Now, let's move on. Now here they asked us calculate the maximum number of electrons that can occupy the 4th energy level. When they want maximum number of electrons, we know the formula, 2n squared. They didn't ask for orbitals. If they asked for orbitals, only n squared. So 4th energy level, so n equals the energy level. So 2 times 4 squared. 4 squared is 16. 16 times 2 is 32. So the maximum number of electrons that can occupy the 4th energy level, which is F, is 32 electrons. Moving on. Now, recognize the maximum number of electrons that can be found in the D subshell. D subshell, I told you. Or no, sorry, it says choose the subshell that can accommodate 10 electrons. So, we know that D subshell is the... Now, what did I say? We have... D has 5 rooms. If in each 1, 2, 3, 4, 5. If in each room you can fit 2, so it can fit a maximum of 10. Memorize it. S can fit a maximum of 2. P can fit a maximum of 6. D 10. F 14. So it's the D subshell that can fit 10. Now here it's electronic configuration, and this is the question that is wrong. This you need a periodic table. MGX is an element, MGX where element X is in period 4. Now what do we know? Mg is 2 plus. So if here we do not have any subscripts, so X must be 2 minus. 2 minus means it has to be in group 6. So if we go to group 6 and to period 4, you find what element there is in group 6 and period 4. So we count 1, 2, 3, 4. It's psyllium, which has protons 34. Now, or it has an atomic number of 34. Now here, we need to know how to write electronic configuration in SPDF. Now, we need to know something. There's something called the backward rule, where you write S, P, D, F, then you write S, S. You do S twice. Then you write P, P, and then you keep doing 2 arrows. What does this mean? It means that you can do SS, then PS, PS, then DPS, then DPS again, then FDPS, then FDPS. Now one thing, S starts from 1. The first S is always labeled 1. The first P is always labeled 2. The first D is always labeled 3. And the first F is always labeled 4. Okay? And like first S is 1, second S is 2, third S is 3, second P is 3, fourth S is 4, and so on. Now S always has a superscript of 2. P always has a superscript of 6. D always has a superscript of 10. And F always has of 14. But we're not going to reach F so far. Now, to write psyllium, which is 34, it has 34 electrons. So you write 1s2, 2s2. Okay, then you move on. 2p6, then again 3s2, because we're moving backwards each time. Then 3p6, then again 4s2. You're going to say, okay, when do I know how to stop? You're going to start adding up these superscripts until you reach 34. Now, this is why I'm telling you this question is wrong. This is supposed to be a 4. You're going to say, didn't you say P always has a 6? Yeah, but let's say we don't have enough to give P 6. Then you can definitely have a 4 up in P. You don't actually you don't need 6. But if you have 4, it stays 4. If you have 6, you can reach maximum 6. Then you move on to the next energy level. You get what I mean? So 1s2, 2s2, 2p6, 3s. And then you continue writing until all your superscripts add up to the number of electrons in the element. Moving on. Okay, so this question, again, you might not understand what's going on, but again, I told you, spot the odd thing. Usually, like I said, always one or most of the answers are wrong because they're made wrong and not because they're had. Now this element has 13, so you need to first of all count. Do you have 13 electrons? Then look if it's wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Nice. Is this one house with up down? Yes. Is this one house with up down? Yes. Is this 3 rooms all with each up down in the correct way? Yes. Then do you go back to S? Always go back to S. This is like the SPDF. S, S, P, S, P, S, D, P, S. You get what I mean. Then here we started a new P house. We don't have 6 more electrons, we only have 1. So you just fill in this 1 room. Let's say this was an element with 14. You fill in 1, 1. Let's say it has 15. This. 16. This. But this has only 13, so it's only 1 upward arrow in the second P subshell. Moving on to the next option. Why is it wrong? First of all, you should know how to spot it from now. Here they moved on to the next energy level without filling this one, that's why it's wrong. Here they moved on to the next subshell without filling up the P subshell, which is wrong. And here they left an entire subshell empty, which is definitely wrong. And that's how you solve most of these questions, honestly. Moving on. Now this is another type of question I doubt is with us, but I'm gonna explain. When they tell you shorthand electronic configuration, you have to look at your periodic table. Look at the element. So this has 26 electrons. What element on the noble gases, which is group 8, has the number of electrons directly less than this one? So it could either be argon with 18 or krypton with 36, but you never go to the one that's more than it. So which one has less? Argon. Argon has 18 electrons. So between brackets you write argon, and we know that argon is 18. So then you continue on to argon. Since argon is 18, always know after argon you start over again with 4s2. I find it like easier than actually writing down the full thing. So if argon has 18, always after argon you start with 4s2 until you finish the number of electrons needed. So argon has 18. 18 plus 2 is 20. So then you have 3d6. At the end, I'm gonna give you a small notice about the D subshell, for it has 2 exceptions. But I'm gonna leave that till the end of the quiz. We have 2 more questions left. So you get what I mean? You do argon because it's the closest one with the same energy, and then you keep doing, you move on directly, memorize it. After argon, you quickly jump onto 4s2, and then you continue how much ever you need left till you reach 26. And if you want, you could write down the full thing and then see which part of it's argon and just continue after it. Like you count till 18 electrons, like you write the full thing. This one's time consuming, but if you were not sure of how to do it, you write down the full SPDF notation. You count 18 electrons, like you add up the superscripts until you reach 18, and you draw a box and you X and you replace it with argon, and then you continue whatever you have left. You could do that. Moving on to the last 2 questions. This question is all just how you write SPDF. So here, you keep writing like I told you, SS, P, then SS, PS, PS, D, PS if you wanted to continue. So you keep writing that until you reach 30. So 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. Plus 6, 18, plus 2 is 20, plus 10 is 30. Then you stop. Now in cobalt, it's 27. So for the last subshell, you stop at 7. Now, here, it's the same as the one above it, except this one is 26. So instead of D being 7, you stop at 6. Now here, SI is only 14, you do the same and you stop at, when you 2 plus 2 is 4, plus 6 is 10, plus 2 is 12, plus 2 is 4. Then you reach 14 and you're done. Please guys, this part can be really confusing in the exam. Please focus because it's really easy, but you can make some very silly mistakes on it. And now for our last question. Removing one s electron from oxygen requires more energy than removing one from a nitrogen because oxygen has a higher nuclear charge. I doubt we have this in with us in the exam. I don't think it's part of our material for this week's exam. So I'm just saying memorize it for now. When we actually take it or when it's actually included in the material, I will explain it because I doubt it's gonna come. But just memorize it that oxygen requires more energy to remove one electron from it than nitrogen because it has a higher nuclear charge. Now, I'm done the quiz for now, but I do have a little note I put somewhere in my notes, which I'm gonna find. So, my teacher told me this one thing. We have two elements which in their D subshell, they're stubborn, which are chromium, they are chromium and copper. Chromium and copper are two exceptions where in their D subshell, they can either have 5 or 10 electrons. You can't have 6 or 7 or whatever. You can't have a subscript of 6, 7, 8, 9, 1, 2, 3. It has to be either 5 or 10. So you're gonna say, okay, let's say I need 6, but you say you can only put 5 or 10. What you're gonna do, if it's, let's say you need 4, and before the D is gonna be, before the D is always gonna be an S. S, we said it's always 2, but let's say the D has 4. You said if it's to these two elements, you can't be 4. It cannot be 4. So what does it do? It takes 1 from the S, for S becomes 1, this becomes 5. Let's say it's S2 and this was 6. We said if it's one of these two elements, it cannot be 6. It has to be 5 or 10. What do? We give 1, we make this 5 and we give 1 here and it becomes S3. These are the only two exceptions what my teacher told me. So memorize these in case they're brought up in an exam. And these two elements, D subshell, they can have only 5 or 10. They cannot have anything more or less. And I think these are the only two exceptions. This video was pretty long for an AMS video, but I hope you understood everything. And I'll see you guys in the next video.